Okay, so we just talked about some of the pros and cons, some of the issues that application developers have working with databases, and I want to do a drill down on a couple of these. The first problem is we talk about an impedance mismatch, this idea that you program in an object-oriented world in Java, but we have a flat relational data model that we work with a relational database. So there's some solutions around doing that. There's several. There's design patterns and other things I mentioned. But this drill down, I want to talk briefly in more depth about object relational mapping and a technique called SQL wrapping. Object relational mapping, right? So you see a class diagram on the left. It has a few associations. Notice how it has a what we call hierarchical or containment style relationship in UML. We actually could even put one of our diamonds there for aggregation or composition. Now, when your object model is flat, meaning we have these flat associations, right? A professor teaches a course or a student takes a course. That's a UML association that's flat in its existence. What do we mean by flat versus non-flat? In an object-oriented world, you know that if you have a class-subclass relationship, right, that you would typically represent with that hollow arrow between some parent class and some subclass or child class. This is a form of hierarchy, right? It's an inheritance or type hierarchy. Another form is if you have a whole to part of, or ISA sometimes it's called, relationship, where you may have a hollow or filled in diamond depending on the life cycle of the objects involved. But the point being, this also creates a kind of hierarchy, and that has kind of a composition tree to it of things. Think of the components of just about anything. Think about the components of, say, an automobile. You may have a car. A car has 4 wheels, a certain number of doors, an engine. You might go inside the engine and look at different parts of the engine and those kinds of things that are under the hood. So you get to this kind of aggregation hierarchy as it is. But in either case, whether we're talking about inheritance, whether we're talking about aggregation or composition, these relationships are not flat anymore. And we get into non-flat hierarchical relationships. It gets a little trickier for a relational database to handle that in some way. You've talked about enhanced or extended, sometimes it's called entity relationship modeling, right? EER kind of stuff. But that's a modeling technique associated with entity relationship. In the flat relational model itself, in these constructs, if we have a hierarchical relationship like we do here with course and prerequisite, the issue is I create this prerequisite down there and it winds up having a foreign key relationship, right? And then prerequisites may have other prerequisites. So let's say I'm trying to form a query where I'm trying to find out, I want to go take, for a secondary focus area in software engineering, I want to go take, I'll make up a course, ABC 456. It's a 400 level course. It's at the a senior level. But to take ABC 456, right, that's a course here. I may have a prerequisite of ABC 345 at the junior level, which is has a prerequisite of ABC 123 at the freshman level. Okay, something like that. Well, what I have is these would be entries, right, both here and here. The tuples for these entities would be inside the course table, but the relationship, these arrows actually is where I should have drawn them, and I made a mess of this, would be in the prereq table, right? This is a classic join table. But the point is, for me to answer the query, I would have to go around this relationship with multiple join queries. Now, of course, this is a well-known problem, and there's certain shorthands. There's things called a connect by query in Oracle and so forth. But the point is in a relational model, it's not natural. It's not part of the data model because it's flat, all right? But it's very natural in object-oriented models. You can see we economically represent it, all right? So we're not too tough when our object relationships are associations, but what happens when they're not, all right? Another issue, do you have to populate all the objects across all referential integrity constraints? Again, if I have, right now we have entities, professor, student, course that we're mapping to a relational table, but what if logically I have a multi-valued attribute, let's say. You've done the EER to relational data model conversion, and I have a weak entity or a multi-valued attribute. You know that we typically factor that off into some kind of parent with a referential integrity constraint coming back to some kind of multi-valued attribute that has multiple rows that I can join back to reconstruct the object. Now in a class, that's just an array. But in a relational model, that violates first normal form, so we can't have that. So again, how do we do that conversion? How do we move back and forth? How do we map that object relationship to the relational array? Or if I start with a relational schema from a pre-existing database and I have to write code for it, how do I do the object model for it? And then once I have the two models, how do I do what's called marshalling data between the two? All right, how do I convert data from one model to the other? So there's a whole sense of issues you deal with these kinds of relationships. Here's an example with dealing with type extension or inheritance. Here's an example, again, with students, but now we subclass them into undergrads and grads, freshmen, underclassmen, master students, PhD students, and the like. Again, maybe you did an EER model where you handled this in different ways, but there were different solutions you could do. You could create a separate table for each class and join them all together. You could union the attributes going down one side of the inheritance hierarchy. You could create one master level object and have these kind of type flags, right? If type equals 1, you're an undergrad. If type equals 2, you're a graduate, that kind of thing. You can use object relational extensions. Again, as object-oriented programming became very popular and object modeling became more popular, traditional relational database vendors had created object relational extensions for things. Or do you treat it as one big cloud? What if I just said, I'm just going to marshal the whole state in XML or serialized objects or JSON or something like that, which means I'll pull a student out as a document effectively and then parse that document to find out if they're an undergraduate and a freshman and so forth, right? And there's expenses obviously associated with that as well. So we've got, we have alternatives, we have techniques, but none of them are clean because we deal with this impedance mismatch, the difference between the data models. So one solution is the Java Persistent Architecture. That's what JPA stands for, Java Persistence Architecture, or API, architecture or API, some people refer to. The point being that the JPA specification abstracts the notion of persistence, meaning as an application programmer in an object-oriented world like Java, or pick any other object-oriented language you want, what I really want to do is say I've got an object or a set of objects in an object graph where those references are being held onto each other, and I want to persist them. I want to basically go to the object and say, persist your state somewhere. As a programmer, that's what I want to do, right? But JDBC doesn't give us that, right? JDBC right now you got to open a connection, you got to form the statement, you got to know what the SQL query would look like. You may have to execute many of them if they're a different hierarchical structure. You have to know when to commit, the transaction demarcation, and all that stuff, all right? So instead, a JPA tries to abstract the notion of persistence, that idea of getting it out of memory, getting it into non-volatile storage, and to act as that invisible relational database, or really any kind of database, but really it's kind of geared toward relational databases because they're so prevalent. Have that be your persistent store behind the objects, right? Developers love using these frameworks because they like to think in objects, right? And in fact, the DBAs love it too because they don't want the developers thinking in SQL and messing around with all these low-level structural concepts. So we have a lot of tools and frameworks around these, okay? I remember the original that came out was something called TopLink. TopLink was a very innovative library at the time, but it was proprietary. Then Hibernate came along, and Hibernate's still with us. You go to hibernate.org, it's open source. You can download the whole framework. The framework actually has multiple parts to it now, of which OR mapping is just one. It basically supplanted an approach to persistence at the time that was prevalent in Java called Enterprise Java Beans, which are really no more, or in very narrow applications. But it supplanted the style of persistence that was done in EJB containers, as they were called. We're not going to worry about that. But effectively, Hibernate was so successful and so prevalent that the Java community process, so Java standards were evolved through something called the JCP, the Java community process. They went out and looked at Hibernate and its popularity and said, well, we basically need to take that and bring it into the community. So they brought it in as the JPA specification. Just like JDBC, JPA as a specification does not provide code. It provides the specification, but Hibernate is the primary provider. It's called a JPA provider now of the specification. So typically if you're using Hibernate, you are JPA compliant in the first place. So that's what kind of thing Hibernate will do for you. It has tools to help you. You can start with a relational schema and generate an object model. You can start from an object model and generate a schema. It generates the queries. You abstract persistence, so you have API calls inside of Hibernate that basically let you persist that object graph, worry about things like caching and the like that we'll talk about in a little bit. And It worries about the magic underneath the hood of the connection to the database, the query that's executed, the result set that comes back, and the marshaling meaning conversion to your object model. All right. Before we were doing conversion by doing our own looping through the result set, and we were printing things out, but we also could have set those as values inside of objects. Well, again, that mapping is all taken care of. All right. So that's what OR mapping frameworks do. Another technique that's not as well known, but one that I really like, is called SQL wrapping. All right. And there's another open source framework out there called MyBatis. It used to be called iBatis for a long time. Now it's called MyBatis. I don't really know why they changed, to tell you the truth. And basically, the MyBatis folks ask, do you really want to avoid SQL, or is it JDBC? Is it all this stuff, right? Here's a typical thing that we write, right? The connection, the prepared statement, the execution of the query to the result set, the looping through, right? All these sets on here, which means employee is kind of, some kind of POJO that has getters and setters on it, and we have to go through and set each of the values. This is marshaling code that I'm talking about. This is conversion code. Right? We're pulling it out of result set rows and putting it into the object, okay? So, do we really have this is, what this whole method is doing is actually quite trivial. We're executing a query against a database, taking the values out, setting it in an object. That's all it does. But JDBC makes it very verbose. Most of the code around here has to do with low-level database stuff like we talked about. Is that what we really want to worry about? I mean, is this really the problem? SQL, you have to realize SQL as a language is a very, very well-established language. You learn it in this class. Everybody learns it in their undergraduate degree. Again, we're going to talk about other non-relational options available, and certainly those things are popular. But SQL is still dominant. Everybody knows it. It's a very widespread tool. So as Martin Fowler says, and this article is still out there, SQL is much more than a simple data update and retrieval mechanism. SQL's query processing can perform many tasks. By hiding SQL, application developers are excluding a powerful tool. So the MyBatis folks say we don't want to hide SQL. We just want to remove the verbosity and complexity of the JDBC low-level plumbing semantics. So they do it in the following way, and this is a very simple example. Let's say I have an employee, a department, and a project. I have a set of classes over my object model, and I want to map these to the select, insert, delete, update states in my relational database. In MyBatis, you would take and make an XML file. Here's just a snippet out of that XML file, where I'd indicate a select query, I'd give it an ID, I'd tell what the parameter was, because this is going to map to a prepared statement, right? I have the query that I'm executing, by the way, is where employee number equals 99, or in some case, or how we really think about it is our question mark, right, that we have for a prepared statement. So we map that to XML and say we're going to have some parameter we're going to bind. It's going to be of type int. The actual query, that parameter is represented with a pound sign or hashtag type in brackets kind of syntax. And we indicate what the result type is going to be as a Java collection, a hash map, what to map it back to. Inside your code, you create a mapper class. You give it what kind of operations. A find is a select operation, an update is your update operation. And then in your application code, instead of writing all that connection, prepared statement, result set kind of stuff, you create a SQL session to represent your stateful conversation over that socket connection. So you ask a MyBatis SQL session factory method to go ahead and open that session. You get the mapper. That mapper has marshaled this. It knows about that, all right? And you go ahead and you call the find emp by ID, passing that integer, and it knows to bind that to this query and get you the employee back. I also, the whole while loop over here, right? That's all gone because MyBatis just took care of it. Now it automatically gets marshaled directly into that employee. And now if I want to do something like updates, I got a little syntax there with a missing brace there. But DML is just as easy. I can take an employee object and set name on it or set whatever on it that's available to me on the object. And I can ask the mapper class, these should be lowercase, to go ahead and execute the update. And it'll go ahead and persist it. And again, I have to write a whole update query and do the persist. I have to do the commit, all right? So SQL mapping does all that for me. MyBatis framework does that for you. There's other examples of wrapping frameworks. Spring used to have one, for example. So SQL mapping works even when the data model does not map to the object model. What that means is these mapping files are quite flexible, and I don't object relation, you tend to have this kind of one-to-one. You directly go from this hierarchical model to flat model, and you work out different ways to flatten your object model to get into the relational model. SQL mapping is working at the SQL level, which means you can actually do some cute mapping kinds of things to ignore some of those hierarchical structures or to shoehorn them in the ways you want. So again, it requires a developer to be far more interested in what the SQL needs to look like. They have to know, you have to write this mapping file. But on the flip side, whereas OR says, you don't, but that lack of transparency also gives you more control and still allows you to use SQL as a powerful tool. So that's an example of some techniques that are out there. As I said, there's other things we've listed before, design patterns and so forth, for still from coding by hand. But this fundamental thing that we're trying to address here is the con of the verbosity and SQL code being everywhere inside of JDBC, and instead structure our code and make it less verbose through a framework. That's what SQL wrappers do. Or object relational just tries to say, you don't even know. You're just talking at the persistence level to persist an object graph.